Hello and good evening, CSI157 Section 841 students from Anne Arundel Community College for the spring 2014 semester. This PacketTracer tutorial will go over all the steps that are required to configure and complete the assignment for PacketTracer activity 9.4.1.2, which is the Skills Integration Challenge. As you can see, we have our topology here on the left. We also have our addressing table here on the right with some information already added to it, and you would want to pull the Word document up and fill this in on your own. And then we have the requirements for what's actually going to be required. There are quite a few steps to this PacketTracer activity. If we look right away at the assessment items, you can see that there are 57 individual tasks that need to be completed as part of this PacketTracer activity. So let's go ahead and dive right in and start with our configuration steps here for the requirements. So as you can see, we need to configure the initial settings on branch A and branch B, including a host name, a banner, the lines, and passwords. So we're going to use Cisco as the privileged exec mode, or I'm sorry, the user exec password, and class as the privileged exec password. And then we want to encrypt all passwords. So let's go ahead and start on branch A. So we'll go ahead and pull branch A up, and we'll take a look at the command line. So we're in we're in user exec right now, and with the enable command that puts us in privilege exec, we're then going to go into global config mode, where the first thing we can do, which is sort of the easiest task, is to go ahead and give the router the name branch-A. So we've set the host name. Now let's go ahead and set up the MOTD banner. And remember, MOTD is message of the day. The $sign I'm placing there, and let me do the question mark first. Oh, whoops. So the question mark is the character that we're going to put there is the delimiting character, and I typically use the $sign. So I would put down, welcome to my router. And we'll just make that the message of the day. Realistically, you'd want to put a message in here indicating that anybody accessing the router illegally would be prosecuted. All right, so we'll go ahead and end the message of the day there with the banner command, and then we want to configure the lines. So we'll go ahead and we'll go into the console configuration. So we'll set the password for the console configuration, and let's see if we need, actually let's check and see if we need any passwords. So Cisco is the user exec, so we'll go ahead and set the password for the console to Cisco just to make sure, and then we'll put login, and then we'll exit back here and we'll go line VTY 0 through 15, and these are the lines that you would connect to if you were using the Telnet or SSH application. And so we'll do password Cisco and then login, and so those have been set. So let's exit one step out to global config mode from line configuration mode, and now I'm going to go ahead and set the enable secret password, and the 0 means it's going to be unencrypted, and this will be the password that will be required to go from user exec mode into privileged exec mode. And so we're going to make that password the user exec, and class is the privileged exec, so we'll make that class. And then we want to make sure we encrypt all passwords. And again, that is the service password encryption command. And so before I run service password encryption, if I do a do show run, we can take a look at the running configuration. You can see that the enable secret command is encrypted already, but when we come down to the lines, you can see here where the line commands are not encrypted. So again, if we were to enter the service password encryption command and now do a do show run, and we come down to the lines, you can see that the lines have been encrypted with an MD5 hash. Okay, all right. So we've encrypted all of our passwords. So the next step, it says LAN A1 is using the subnet 172.20.16.0/23. And it asks us to assign the next available subnet to LAN A2 for a maximum of 254 hosts. And I'm sorry, for 250 hosts. And so we know that a class C or a /24 will provide us with enough IP addresses to accommodate 250 hosts. And so LAN B1, which is on the IPv6 side, is using this subnet, and then it says assign the next available subnet to LAN B2. And so these are a little more difficult than they appear for a beginning student, because we're going to be dealing with a Class B address here, as well as a Class B subnet, in addition to the fact that they've placed here the 00FF, and so we need to make sure that we understand what the next subnet would be in this range. And again, it's not as simple as 000A, and so then the next one would be B, or 0001, and then the next subnet would be 2. And so they've made that a little tricky here on this part. So it says finish documenting the addressing scheme in the addressing table using the following guidelines. So assign the first IP address for LAN A1, A2, B1, and B2 to the router interface. And so we're going to go ahead and we'll do that right now. First, we're on router A, and so then moving that out of the way, you can see here that the gig 0 interface is out on LAN A1, and that the gig 01 interface is on LAN A2, and the gig 02 interface comes out here to the central WAN and then out to the DNS server. And so in sticking with router for the router branch A, let's go ahead and do the configuration for the 3 interfaces that we see here on branch A. And so the easiest one for us to get to is going to be the one that's provided for us. And so that's gig 02. So if I type in int gi0/2, we're going to do a no shut on that interface, and you can see the status changes to up. I'm going to go ahead and add in the IP address, and that is a 172.20.31.254, and the subnet mask is 255.252 or a /30, and you can see that that's also printed up in the logical topology diagram that we have above us. So I'm going to put a description, and we'll say that this is interface to WAN. All right. So we've configured the gig 02 interface with the information that's been provided, which is right here for branch A. But now let's come down and take a look. So LAN A1 is using the subnet 172.20.16.0. And so we know that we need to assign the first IP address for LAN A1, A2, B1, and B2 to the router interface. So if I go to interface gigabit Ethernet 00, and let's confirm that it is in fact that interface right there. So gig 00 comes out here to LAN A1. So let me pull the router back up. So the first thing we will do is no shut, and it shows us the interface is coming up. We're going to go ahead and assign the IP address, which is going to be 172.16, used to typing .16.20.16.1, and the key here is going to be that the subnet mask is 255.255.254.0, because again, we're dealing with the /23. And so if I were to come over here to the sheet, so a /23 would look like this in binary: 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 0, and then the rest of these are the last octet. Make sure I get this right: 1 2 3 4 5 6 7, and then 8. 1 2 3 4 5 6 7 8. All right, so the last octet is all zeros, and the last bit in the third octet is also a host bit. So we've got 9 host bits, right? So 9 host bits, which means if there's 32 possible bits, the other 23 are for networks, right? Or the network bits, okay? And so when we take a look at this, you can see that the subnet we're dealing with is a 172.20.16.0/23. And again, this is a Class B address. So we'll do class B, right, because it's a 172. And the class B address has been subnetted down, and it's had 7 host bits have been masked with network bits. And so in order for us to calculate, the number of subnets that we could create, or the number of usable subnets, we know that 2 to the 7 is equal to 128. And so this equation that we've used previously when we've been doing class C subnetting, right, subnetting a class C address, still holds true, okay? And it also holds true when we start to take a look at the number of hosts, right? So there's 9 host bits, and we know the equation for hosts is 2 to the 9 minus 2, or you could say 2 to the n, where n is it's representing the host bits, but we know that there are 9 host bits in a /23, and so 2 to the 9 minus 2 is 510. So you could have a total of 510 usable host addresses. And so this is a little different than some of the other subnetting that we've been dealing with, where we've got a /25 or a /26, and we're dealing with much smaller numbers. But here, with this class B with this class B address and the subnet mask that we've applied, we can have up to 510 hosts and 128 subnets, right? So that's quite a large amount of subnets. Now, remember, prior to this, when we were talking about the block size of the address, we were dealing with the last octet, right? And then we would determine how many host bits were left, and we would do 2 to the number of host bits, and that would give us our block size. And so here, what we need to remember is we're dealing with the /23, which means that this is the interesting octet right here, right? So let's put a little star here. So this is the interesting octet here, where we have a single 0 in the host bit spot. And so 2 to the 1, right, for the number of host bits in that octet is 2. And so when we look at this IP address, right, we're looking at this is our interesting octet here, the 3rd octet. And so the block size inside that 3rd octet for our subnets is going to be 2, which means that in this network, our usable IP address space will be 172.20.16.0 to 172.20.17. And let me get my eraser here real quick. I apologize there. Get the eraser here. All right, go back to our pin. So .17.254. Whoops. All right, .254. And so this is our valid range. And actually, if we're saying usable addresses, it would be 254. Let me go ahead and drop this guy out of here real quick. So we'll actually put the range here. So it would go all the way up to 255. So I've got the network ID here. So I might as well have the broadcast address here to make sure. Keep it the same as we've done previously. So our usable addresses are going to be from .16.1 all the way up to .17.254. And so the block size, when we see that 2 for our block size, it's going to impact this 3rd octet. So the next network is actually, and I'll flip the page here, we'll leave it here for just one more second. So those are our usable host IPs that we can assign, and you can see that there are 510 of them in here, right? Because you figure we're doing 254 here, right? And then another about 254, so 17.254. So it's going to be shy of that, but they will add up to 510 usable. And so the next subnet would be 172.20.18.0, right? And so that would be the next subnet. after that /23. And so that's where it gets a little tricky, because again, with the Class C addresses, previously what we saw was it was very simple to manipulate that 4th octet. Here you've got to manipulate the 3rd octet. So this would be the next usable subnet. Whoops. That would be the next usable subnet, and that's what they're referring to. All right. So let's switch back over here. So again, the IP address for the gig 00 interface is going to be 172.20.16.1, and the subnet mask is 255.255.254 because it's a /23.0. And I'll put a description on this interface and just basically say LAN A1 interface. Okay, so now we've got the gig 00 interface configured. So now let's go ahead and go into the gig 01 interface. And so this is where it gets interesting, because when we go to do this interface, this is where, for this gig 01 interface, we would be using the next available, because we're doing LAN A2 now. It says assign the next available subnet to LAN A2 for a maximum of 254 hosts. And so again, this one's a little easier, and we know that to have 254 hosts, I'm sorry, to be able to accommodate 250 hosts, then we can use a /24, which is a little easier to deal with, which means we're going to be able to hold up to 254 hosts, right? And so this would be our subnet. So our first usable IP would be .18.1. Our last usable is going to be .18.254. This is our network ID, and our broadcast address, as you would expect, is going to be .18.255. Okay, so let's see if this holds up. I'm going to move back over here, and we're going to configure that interface. First, I'll do a no shut to bring the line up, and then I'll add in the IP address. And so again, we want to make sure that the first IP is the router interface, and so that's going to be 172.20. I keep wanting to type .16. .20.18.1, and again, very standard default Class C subnet mask being applied to a Class A address. And we'll put our description on here, and we're just basically going to say LAN A2 interface. Okay, so at this point on the branch A router, we've configured everything for the initial requirements here, right? Now we've gone through and configured and actually figured out what our subnetting is going to look like. We've dealt with the /23. We've actually been able to calculate what that is going to look like for the second subnet as well. And so let's go ahead and end our session here, and I'm going to write mem and save my configuration. Let's do a show run and take a quick peek, see what we've got. Okay, so gig 00, 01, 02, everything looks good. And so let's go ahead and we'll close that down. Let me pull this down a little bit further. All right, so LAN B1 is using the following subnet. It's a IPv6 address. And if you remember from class, right, we talked about the 314 when you're dealing with the hextets. So the first 3, which is your /48, is your global routing prefix. The next hextet, or the next 16 bits, the 1, this is where you do your subnetting, right? And you can certainly subnet down further, but for the purposes of this exercise and what we've spoken about in class so far, is the 1 is the subnet hextet, and then the last 4 hextets, or 64 bits, those are going to be your interface IDs. And so this is the hextet we're concerned about right here, right, in terms of figuring out assign the next available subnet to LAN B2. All right, so let's go ahead and pull up the branch B router and pull up the command line interface here. And again, the easy first step is going to be the information that's already been provided. So I'm going to go from user exec mode into privilege exec, and then from privilege exec into global config. And let's go ahead and go into interface gigabit Ethernet 0/2. So the first thing I'm going to do is a no shut to bring the line up, And then let's do our IPv6 address, remembering that we need the IPv6 command, because this is going to be an IPv6 address, and it's DB8 :1234:1234:2, and then we'll put our /64 here at the end. I'm going to add a description to this line, and let me make sure I've got this correct, and that's just simply the interface out to the WAN. So we'll say interface to WAN for our description. Okay, now this is where it gets a little tricky in dealing with IPv6 addresses, and so let's get a fresh page here, and so we're going to be talking about IPv6, right? And we know from our studies that IPv6 addresses are 128 bits, and they're broken up into 8 hextets, right? So 8 hextets divided by colons, and they're hexadecimal characters that represent the IPv6 addresses. So with our exercise here, we're looking at 2001 : and then it is DB, so DB8 : and then we've got FADE, and so again, this is our global routing prefix, the first 48 bits, right, or the first 3 hextets. This entire series here is our global prefix, and then we're going to come in here, and so that's the 3. The 1, right, which is where we're going to be interested to do our subnetting, is currently 00FF, and then you've got your : /64. All right, so the 00FF is what we're interested in, because we need to know, hey, what is the next subnet going to be here? So remember that FF, the F character in hex, is the last available alphabetic character before you go back to 0. And so what our 4th hextet is going to be after the colon here, it's going to be 0100, right? So we increment this one here from 0 to 1, and this gets incremented from F to 0 and from F to 0. And so this is going to be the subnet we're going to be dealing with, and again, it's going to be : /64, and the first 3 hextets, right, those will also be right here. Okay, so those guys would come down here, but this is our subnet address, and that's what's going to be critical. And again, what I had previously mentioned was, if it was something simple like 0001, then we would know that the next subnet would be 2, and then 3, and then 4, and so forth and so on. But here, they made it a little challenging by showing you FF and hoping that you would be able to figure out that this would get incremented, and then these guys would be changed to zeros, right, from F and F. All right, so let's see what that looks like on our interfaces here. And I believe we've done gig 02, and so we'll go with the easier of the 2. We'll get the easy one first, and I believe that's going to be this guy right here, gig 00, and it is. So let's go ahead and configure gig 00. Let me scoot over here. So I'll go int gi 0/0, and first we'll do a no shut to bring that interface up. And I'm going to go ahead and assign my IPv6 address. So again, we use the IPv6 address, and so we know that it shows us the subnet here. And again, this isn't the one we manipulated, right? This isn't the one that we went one up on. This is the original one. So it'll be LAN B2 where we use the information that we calculated over here. So right now we're going to use this guy right here. So the IP address will be 2001 : DB8 : FADE : 00FF : 1, and let me actually confirm that. Let's make sure that the first IP address, so it is the first IP address, and then we'll say /64. All right, and we'll put a description on here, and we'll just basically say LAN B1, and we'll even put in IPv6 interface. Okay, And so that was for gig 00. Now let's transition to gig 0/1, which is going to put us on LAN Baker 2 or B2. So I'll do a no shut to bring the interface up, and then I'm going to apply the IPv6 address. And now this is where we want to use the information that we figured out with the next subnet. So it's going to be 2001:DB8:FADE:, and now remember, it's not going to be 00FF because that was the original subnet above us. This is going to be 0100:1/64, right? And if you remember this from over here, this is where we incremented it, right? We took the next subnet after 00 Fox is 0100. And if you remember, you can have up to 65,536 subnets, and that is simply by using the 16 bits that are in here, because 2 to the 16 is 65,536. Okay. So we have our address assigned. Let's go ahead and add our description really quick. So we'll say LAN B2 IPv6 interface. All right. And then we're going to go ahead and type end. And we're going to do a write mem to save our configuration. And then let's come back over here and take a look. So we've configured LAN A. We've got LAN B1, B2 is done, finished documenting. Okay, we've got the the IP addresses assigned properly here. We're good here. So for the IPv4 networks, assign the last IPv4 address to the PCs. Okay, so again, we're going to jump on PCA1 first. We'll pull the desktop up here and we'll take a look at the configuration. So the last IP address, which we looked at earlier, 172.20.16. Oh, I'm sorry. So what the last IP address is going to be .17.254. Now it gives us that default class B, but we know we need to change that to a 255.255.254.0. All right, and then the default gateway here is going to be 172.20.16.1. And the DNS server is provided for us here in the diagram. So it's going to be 172.20.32.10. All right. And so we can do a real quick check here. So let's give it a ping. 172.20.16.1. So can I ping my default gateway? I can. Let's see. Can I ping the interface on the router, which is going to be 172.20.31.250, or actually we're going to go all the way out to the DNS server. I apologize. 32.10. Can I ping the DNS server? See if I can get out there. All right, the request is timing out. And we may not be able to get out there just yet. Oh, we can. All right. So good. So we can ping the DNS server. So again, I'm going from PCA. I can ping my default gateway here, but then I can also ping all the way out here to the DNS server. So I'm doing my connectivity tests right now. All right, so PCA1 has been configured. Now let's pull up PCA2 because this guy is going to be a little different. So this was our 172.20.18, and we know the last usable IP is 254. The subnet mask defaults to a Class B because that is a Class B address, but we know we've applied a Class C subnet of /24. All right, our default gateway is going to be 172.20.18.1, and our DNS server is that same DNS server from as before, 172.20.32.10. All right, so let's do a quick check here. Can I ping my default gateway, 172.20.18.1? I can. Let me see if I can ping out to that 32.10. Oops, 32.10. All right, fantastic. And I can ping all the way out to the DNS server without any problems. So I've got connectivity from PCA2. All right, so let's do a quick check on our configuration items and let's see what it looks like here. So branch A looks really good, right? Branch B, we haven't done a whole lot. So PCA1 is good and PCA2 is good. And so you can see we've got PCB1 and B2 over on the branch 2 side, or the branch B side, I should say. And you can see we still have some information we need to fill in here. Oh, and I'm going to have to go back and do my link local addresses as well. So it's good to come in and check your progress every now and then. I think the link local information is provided. Here it is. Yep, it's right down in here. All right. So for the IPv4 networks, assign the last IPv4 address to the PCs. So for the IPv6 networks, assign the 16th IPv6 address to the PCs. And again, they try to get a little tricky here with you. And so you've got to kind of think this through. So we'll take a look at the desktop. And so we're going to come down here. We're going to be statically configuring these IPv6 addresses. And so for Baker 1, we know that it's 2001:DB8:FADE:00 00:::. And so this is where they try to get a little tricky. So they want the 16th address. Well, if you count it out from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E, F, right? Where F is the 15th character, the 16th character, very similar to how they had you change the subnet, that F would then change to 10 if you continue to go up, right? If you continue to increment. And so it's going to be a /64. Our link local address is already set. Our IPv6 gateway is going to be, that's our default gateway, so it's going to be the router interface on our subnet. And so for us, it's going to be 2001:DB8:FADE:00:FF::, and we assign the first usable IP address. All right, the IPv6 DNS server. If you take a look here, they provide that information for us, so it's really just a matter of filling that in, DB8:FADE:10:10. And it's kind of interesting, they actually use the 16th address here, right? They don't tell you that they are, but that's what they're doing there. All right, so I'm going to go ahead and close this guy down. Now let's see if we can do a ping out there to 2001:DB8:FADE:3::10. All right, and so we can ping all the way out to the DNS server. How about if I come back in here, we'll change that to, whoops, leave it at fade, and then 00::::1, which is my address assigned to the default gateway. Now, interestingly enough, what's going to happen is we're going to want to change this, our default gateway. We haven't assigned it yet, but we will here in a second. And we would make that FE80::B the link local address. So we won't be able to ping it yet. And in fact, let me go back and let's drop those guys on there right now. So I'll go into global config mode, interface gigabit 00, and we're going to do IPv6 address, and we're going to make it FE80::Baker, and we want to make sure we define that as the link local address. And then the same thing for gigabit Ethernet 0/1, and I'll go ahead and put in IPv6 address FE80::Baker. And remember, the reason it's a link local address is that it is locally significant on that link. And you can substitute subnet for link. And so we can assign that same address. I can go out to gigabit Ethernet 02 as well. And I've assigned that same address to 3 different interfaces on the same router. So if I do a show run, you'll see that the link local address for all 3 interfaces, gig 00, 01, and 02, is FE80::Baker, because again, it's locally significant. And so now if I pull up PC Baker 1, which we were working with earlier, you can see we've got the default gateway there. I can ping FE80::Baker, and now that works. And in fact, you will always want to use the link local address if you can. If one's assigned and you know what it is, that's the address that you're going to want to use as the default gateway for your hosts. Okay, now we'll come down to PC Baker 2, And again, this was on the subnet that we had to manipulate. So we're going to go ahead and go with 2001:DB8:FADE:0100. So remember, we had to change that. We incremented the 00FF up 1 to the next subnet, which would be 0100. And I'll go ahead and do : and we're going to have the 16th address. So again, it's going to be 10, and I put 64 in here. The link local address is set. The IPv6 gateway is going to be our FE80, our link local address, : Baker. And the IPv6 DNS server, that information again is provided for us out here. So we'll type in 2001:DB8:FADE:1000:10. All right, and let's see if I have some success here. So FE80: : Baker. All right, fantastic. I can ping right away. And let's go ahead and try to ping again out to 2001:DB8 fade 1000:10. Can I get the DNS server? I certainly can. So we've got connectivity there. So everything looks great from the host perspective. Let's just go ahead and check this and make sure that everything else is set up the way it should be. Verify connectivity. So verify that the IPv4 PCs can hit the web page at central.pka. So let's give that a shot. So we'll try central.pka. All right, welcome to Central, so that works. Let's try it from PCA2. Pull the web browser up and we'll go to central.pka. Welcome to Central, so we're good there. PC Baker 1, we're going to go to Central v6, Central v6.pka. All right, that works fantastic. And then lastly, PC Baker 2. And let's see what we've got here. So we'll go to Central v6.pka, and we've got connectivity. So our final check, you can see here completion 68 out of 75. So we can already see we've got some tasks that are still left. So let's go ahead and check our results and see what those tasks are. So our banner message of the day. So we've got some basic configuration tasks and the passwords for the VTY lines. Okay, so we've got to do some basic configuration on branch B still. So let's close that down. We'll pull branch B up. And we're going to need to walk through those basic tasks very quickly here. So config T. So first thing we'll do is the host name. So branch B is the name of this router. And you can see the host name has been changed. Let's go ahead and put a banner in here. Banner MOTD. We'll do the $ as the delimiting character. This is my banner message. Welcome. And then a $. So now we have our banner in there. We're going to go ahead and configure the console line. So we'll do line con 0, and we're going to set the password to Cisco. Oops, sorry. Set the password to Cisco, and then log in. And then we're going to go out and go into the VTY lines, the 0 through 15, and we'll set the password to Cisco and require it upon login. And oops, so I'm going to stay in global config mode here, because we want to make sure that we get the enable secret password as class. And then finally, we want to make sure that all passwords, service password encryption command is run so that the console or the lines all have their passwords encrypted. All right, so let's do an in and a write mem. And we are 75 out of 75. So let's close this out and let's take a look at our results here. So we should have everything configured. We are 75 out of 75. All 57 items have been completed. So we just take a quick scroll down. And as you can see, we've got green checks next to everything. And so that is the tutorial and solution set for PacketTracer Activity 9.4.1.2, the Skills Integration Challenge from Chapter 9. I hope that you found this video tutorial helpful, and I will see you all on Tuesday evening. Enjoy the rest of your weekend.